get it. All right, the rational zero test. If the polynomial function f of x has integer coefficients, so you've got coefficients, okay? Then any rational zero of f will be of the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. It sounds pretty confusing. It's really not, so I'll show you. And yes, how I model it is how I want you to do it, okay? So the first thing is p is the constant. So what's the constant? And we don't care about the negatives or positive. What's the constant? 6. Okay, so what are the factors of 6? What times what will give me 6? 1 and 6, so I'm going to do plus or minus 1 times plus or minus 6. Okay, what else? Yeah, 2 plus or minus 2 plus or minus 3. And yes, you have to put plus or minus no matter if it's positive or negative. You always put the plus and minuses, okay? The next thing, Q is the coefficient for the leading term. So is it in descending order? Yes. What's the coefficient? 1. So what times what gives me 1? 1. And again, you have to do plus or minus. So what we're going to do is we can figure out any rational zero. Rational means what? Remember rational versus irrational? It was the very first day I taught you something new. Oh yeah, way back. Rational is a fraction that either terminates, so divides evenly, 8 over 4, or it repeats, like 1/3, 2/3, right? 3/4 terminates or repeats. So what we're getting ready to do, P over Q, is going to tell me if it's a 0 and it's rational, I'm getting ready to list all the possible ones. It's pretty cool. So P over Q then, and then you literally just divide every P by every Q. So 1 divided by 1 is 1. 6 divided by 1 is 6. 2 divided by 1 and 3 divided by 1. Now, because I'm a math teacher and I have OCD about things being in order, I rewrite it smallest to biggest, because typically, not always, but typically your 0 is going to be closer to the origin, to 0, okay? So I always write it smallest to biggest, and then I just try -1, then +1, then -2 and +2, then -3, or whatever, okay? All right, so let's do this next one. What's P? 3. We don't care about the negative, okay? I mean, I'm glad you know it's negative, but for this, we don't care because we always put plus or minus. And the factors? 1 and 3. Okay, what's Q? 2. So what are the factors? 1 and 2. Whoop, pump the brakes. 1 and 2. All right, so P over Q, which is my possible rational zeros, would be 1 divided by 1, which is 1. 1 divided by 2, which is just 1/2. 3 divided by 1, and 3 divided by 2, 3/2. And then because I have OCD, plus or minus 1/2, plus or minus 1, plus or minus 3/2, plus or minus 3. I just always put them in order. It's a math thing. You don't have to. Nope. You have to do this, list your P and Q, and then list the factors, and then you have to just tell me what's P over Q. So no, you don't have to put them in order. Any questions? So do you realize what I'm saying to you by giving you P over Q? Instead of giving you the factors and saying verify that these are the zeros and then factor the remaining, find the rest, I can just give you this problem now and say find the zeros. And then you can just start trying these. Now, how am I going to figure out if they are in fact a rational zero? What would I do? How do we know when something's a 0? You what? Plug it into what? The equation? Ah. Or I could just do synthetic division which is easier a lot of times than trying to plug that number in without a calculator, right? I don't want to plug into the 4th power because we don't use calculators in here, right? Yeah. So what you would do is you would put these, and then in the box you would just start trying these. So how would I know it's a 0 then if I'm doing synthetic division? Remainder of 0. Okay? You see where I'm leading you to? Hang on. Let me show you something else before you ask me that question. Okay? So let me say this too. Let me back up. What is this called? The rational 0 test. Rational. That means there could be irrational zeros. We just don't have a way of finding, like listing what they could be possibly. Okay? Irrational, remember irrational numbers? Pi, square root of 2, stuff like that. So this is just rational. Okay? So keep that in mind. The next thing is called Descartes' rule of signs, not Descartes' rule of signs. It's Descartes, okay? So Descartes' rule of signs tells us that the number of positive real zeros of f is either equal to the number of changes in sign of f of x or less than that number by an even integer. Again, it sounds very confusing. When I show you, you're going to go, oh, okay. I promise, it's not bad. May God bless you. The number of negative real zeros, and again, I'm emphasizing the word real because sometimes we have imaginary, right? So negative real zeros of f is either equal to the number of changes in sign of f of negative x, so you see what you're going to have to do. Plug in negative x. Count the number of sign changes, and then again, it's that number or minus the next even integer, and that sounds really confusing. So let me just show you what I'm talking about with an example, okay? So the first thing, describe the possible real zeros. So positive real zeros. And all you have to do is count the number of sign changes. What are the signs? Positive or negative, right? So if I'm right here, this is a positive, and then I go to negative, so that's a sign change, right? So 1, then from here to here, did the sign change? 2, from here to here, did the sign change? So there are 2 sign changes. But listen, it says it's either that number or less than that number by an even integer. That sounds really confusing. Let me tell you what to do. Once you get this number, are you all listening? I don't care what that number is. I don't care. Always subtract 2, because that's even, 2, until you get to 1 or 0. So if that's a 2 and I subtract 2, what do I get? 0. So you know what that tells me? There's either 2 positive real zeros or there's none. That's what I just found out. There's either 2 positive reals or none. So now we have to figure out how many negative, but before we can do that, we have to plug in negative x. So f of negative x equals 2 times negative x cubed minus negative x squared plus negative x plus 4. Does the sign change when the exponent is odd? Yes, because it's a negative times a negative times a negative. So this becomes negative 2x cubed. Does the sign change when it's an even exponent? No, because negative x squared, you have to do that part first, right? Order of operations. It's squared, so what happens? It's positive, and then you just bring that sign down. Okay, this is x to the first power. Does the sign change? So it's minus x and then plus 4. So if the exponent is odd, the sign changes. If the exponent's even, the sign doesn't change. And then you just count the sign changes. Here is negative, here's negative. Didn't change. Negative, negative, didn't change. Negative, positive, so it changed. So I have 1 negative real 0. Why am I not subtracting 2? I told you to always subtract 2. Till you get to 1 or 0. So if you start with a 1, you're already there. You only subtract 2 if you start with something bigger than 1. Okay? So what you just discovered, and I'm not going to make you find the zeros, you just discovered that this cubic function has either 2 or none positive real zeros, so bigger than the origin, and it definitely has 1 negative real zero. So I would try to find that negative real zero first, because once you find 1 zero, what happens? You get a depressed polynomial, right? Well, if it starts as a cube, you find that 1 negative, what's it going to end up as? A quadratic, and then we know how to factor or do quadratic formula, right? All right, so now we're going to put everything together. So for the next 3 examples, and I want to say it's actually only 2, but whatever. Who needs to count in math class? Actually, I think I took one out because they take so long, okay? For the next examples, we're going to find the real zeros of the polynomial function. We're first going to use the rational root theorem to see what they could be. Then we're going to use Descartes' rule of signs so that we can narrow down the number of choices, okay? And then hint, people forget this, and I say it all the time, but I'm going to put stars even. Remember, once you find one of the zeros, use that depressed polynomial from then on. Then if you find another one, now use that new depressed polynomial. And what do you want to do? How far do you have to work it down? To a quadratic. Could you keep going? Yeah, and work it down to a linear, but you don't have to. I stop at quadratic because you can factor it or do quadratic formula. Okay? All right, so first thing, rational root theorem. What was that? What was the rational root theorem? Your P's and Q's. So what's P? 6. So what are the factors for 6? 1 and 6 and 2 and 3. Good. Okay. What's Q? 2. So what are the factors for 2? 1 and 2. Okay. So now my possible zeros, my rational zeros, yeah, I literally just do 1 over 1, which is 1, and then 1 over 2, which is 1/2. And then I do 6 over 1, which is 6, and then 6 over 2, which is 3. Then I do 2 over 1, which is 2. Then I do 2 over 2, which is 1. Don't you already have 1 listed? So don't write it again. There's no point. I mean, you can, and then if you rewrite it like I do, then just write it once. Okay. So I'll put it. That's fine. I just don't write it again, but that's fine. 2 over 2. So now 3 over 2, and then 3 over 1 is 3. But look, you have a 1 right here, a 1 right here, a 3 right here, and a 3 right here. So I'm not going to list that one again. I'm not going to list that one again. So if I put them in order, it's going to be 1/2, 1. 3 halves is smaller. That's okay. 3 halves, then 2, then 3, then 6. Is that enough? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? The next thing I need to do is what? That's rational root theorem. Look at the signs. Yep, Descartes' rule. Very good. Okay? So how many times does the sign change? Positive goes to negative. So there's 1, negative, negative. Nope, negative, negative. Nope, negative, negative. Nope, negative, positive. So positive real zeros. There's either 2 or none. Always subtract 2 until you get 1 or 0. So there's either 2 or none. Okay? Negative, I have to do a little work first. What do I have to do? Make it negative x, right? So what did I say about if it's an odd exponent? It turns negative. Good, Marwan. Okay? If it's even, it stays whatever it is. So if it's a minus, it's going to stay a minus. If it were plus, it would stay a plus. So if it's an even index, not index, that's radicals. If it's an even exponent, the sign just stays the same. Okay? So if this is a cube, what happens? To plus 12x cubed. This is even, so stays negative 8x squared. Okay, that's odd, so plus 5x and then plus 6. And now I'm going to count my sign changes. So I go negative, negative, nope, negative, positive, positive, negative, negative, positive, positive, positive. So how many? 3, and then subtract 2 until you get to 1 or 0. So you have 3 or 1. Ooh, so we definitely have a 0 that's negative. That's what that tells me, right? So do you want to find that negative one first or not? Here's the word of caution that I'll tell you, because first block was like, what? So I want to do a better job with y'all, because I kind of confused them. Positive real zeros, negative real zeros. Just because it's a real zero doesn't mean it has to be rational. Meaning, you could try every one of these negatives and none of them work. And then you go, wait, but I'm supposed to have one. Well, it might be irrational, right? You don't know. So it's okay if you try all the negatives and you never get a 0, because that just tells me it's irrational. All right? So what do you want to try? You want to start here and work your way up the list? Yeah. So you want to do plus or minus 1/2? Let's do plus. Okay, I'm going to do it right here. I'm just going to tell you this. You probably don't have enough room. So you probably just want to get out a sheet of paper to do all this synthetic division, okay? Everybody writes different sizes, so there's no way for me to know how much space to leave, so just get out a sheet of paper, okay? So we're going to use, y'all said positive 1/2, right? Yeah. Okay, and then we're going to use our leading coefficients, or our coefficients, not leading, our coefficients. Is it in descending order? Yes. Is every term present? Yes. So I'm going to list 2, -1, -12, -8, -5, and 6. Whew, we started as a 5th degree. Keep that in mind, because once we find 1 0, then it's a 4th degree. Yep. All right, so first step is to bring down the 2. What's half of 2? 1. So -1 and 1 is 0 times 1/2 is 0. -12. Half of -12? -8 plus -6. Half of -14. Add them together. Half of -12. Man, y'all guessed good. You just found a 0. Ooh, I found a positive. So what does that tell me? So there's another one. However, does it have to be rational? No. It may be, but it doesn't have to be. Okay? It could be irrational, which kind of sucks if it is, because then what are we going to do? You know what I mean? Okay, so right here is a depressed polynomial. It started as a 5th degree, so now it's a 4th degree. Once you find it, let me write it. I didn't write this first block, and then I did later. Once you find it, what am I going to say? Use it. Once you find one that works, now we're going to use this depressed polynomial. Once you find it, use it, okay? You want to try -1/2, or you want to try something else? Another positive? Let's say positive. I like that. Okay? So tell me what that row was. It was a 2. It was a 0. Yeah, and you know not to write the 0, the remainder. You know not to write that, right? Okay, good. Just checking. All right, what do you want to try? I forgot to put the what? Oh, you want me to use a 1? Y'all all want to use positive 1? Okay, fine. We used 1/2, yes? Now we're using 1. Okay, so bring down the 2. 2 times 1 is 2 plus 0. -10, -12 plus 2 is -10, clearly, because I already answered it. -14, -10, -24 times 1. Ah, boo. It didn't work. Oh well, let's try something else. You still use that top row, 2, 0, -12, -14, -12. You don't get to change what you're using until you find another one. Hang 10, Ashton. Stay tuned. Keep going until you find one. Go. Once you find it, let us all know. That way we can use it. Welcome back. Yeah. Someone found a 0, so we're confirming. Oops. Okay, negative 14 and 18 is 4. 4 times 3 is 12, and you get 0. So was she correct? Yes. For the first time, no. You found another positive 0. So how many positive zeros have we found? So should I keep trying positive numbers? No, because you found 2. So that's it. So now, well, we started as a 5th degree. We got it to a 4th degree. So now it's a 3rd degree. So yeah, do we have to find another one? Yeah. You're saying negative 2 works? Ooh, someone else just said it. Am I going to use this row again of 2, 0, negative 12? No. What am I going to use? The new one. 2, 6, 6, 4. Good job. Okay. Bring down the 2. Negative 4, 2, negative 4, 2, negative 4. Man, that was fun. Somebody else set it up here. Who was it? Yeah, it was 2 people. So it started as a cube. Now it's a quadratic. So 2x squared plus 2x plus 2. I don't have to keep trying things. You have a GCF. What is the GCF? 2. He's got your back. Don't worry. Well, here's the deal. You always set the factors equal to 0. 2 equals 0 is not going to give me anything. X squared plus 1x. I don't know why I'm writing 1x. Whatever. I'm tired. Okay. Can you factor that? What times what will give me 1? 1. But when you add those, you could get a 2. So what can we do? No sliding and dividing. What? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, here's the deal. Stop. Because first block asked me. They said, do we use 2 or do we use 1s? It is up to you, but I'll tell you this. If you factor out a GCF, right, that means y'all have something in common. So you're going to have to simplify at the end with a radical. Unless you use what you've simplified already, right, the 1s. So it's going to be in simplest form, and you may not have to simplify the radical. You see what I'm saying? I always use the smallest numbers. So I'm going to plug in that. You can plug in the 2s. I'm down with it. You do you. But I like smaller numbers. They make me happy. So negative 1 plus or minus 1 minus 4. Negative 3. So what just happened? It's imaginary. So guess what, y'all? There were only 2 positives, right? Did we ever find a negative? Did we find one negative? Negative 2. So we found a negative. So we were supposed to have 3 or 1 real 0. We have 1. And the other 2 are imaginary. So what were the directions? Find the zeros. So now I just need to list them. Oops. So they were what? What are my zeros? What was the first one we got to work? A half? Yeah. So 1/2 0. Then we got what else? 3. Because Peyton found it and had to work hard to get you to believe her. Some of us. It's cool. I love you. Move on. Okay. And then we got negative 2. How am I going to list that? One of them would be negative 1 minus I squared of 3 over 2, 0. And the other one would be negative 1 plus I squared of 3. What, on the graph? No. Did it say find the real zeros or zeros? Does it say real? Oh, then yeah, I don't need to do that. Sorry. Well, it's good for you to see how to do it. If it said list the zeros, you would do that. But if it says list the real zeros, then you're good right there. I'm in its way. Okay, are you good? Can we move on? Keep going. So she asked a while ago, she said, are we going to have to try all of these numbers, or is there an easier way? Okay? So, however, listen, because people, I think, when you hear the word easy, you're like, oh, yeah, it's going to be easy. No, I said an easier way than just plugging in all those numbers. Do you realize how many numbers we could have potentially had to plug in on that problem? 2, 4, 6, 8, 10, 12. 12 numbers. We could have been there a while, right? That's why I said work and try to find them and then let us know when you find them. So y'all did really great as a group. I'm proud of you. But if we are by ourselves at home working this, which is what happens, how can we narrow down our choices even further? Okay, so first you want to find the upper, I need to get a pen, the upper and lower bounds. Okay, the upper bound means there's not going to be a zero bigger than that number. The lower bound means there's not going to be a zero less than that number, okay? And I'm going to show you how to find the upper bound. So the upper bound is the smallest non-negative. Non-negative means positive. So the smallest positive value of x that produces a row of positive numbers. Row of positive numbers. I'm going to underline that several times. Row of positive numbers. And let me put something right here with a star. 0 can be whatever you need it to be. Meaning, if you need 0 to be positive to make a row of positive, cool, it's positive. If you need 0 to be negative to make a row of alternating signs, you can make 0 negative. It can be whatever you need it to be, okay? So the lower bound is non-positive. What's non-positive? Negative. Negative x that produces a row of numbers which alternate in sign. Meaning if the first one's plus, the second one has to be minus, then plus, then minus, then plus, then minus. If the first one's negative, the second one has to be positive, and then you have to keep alternating, okay? So let me actually show you. We're going to do this example, okay? I hope you have enough space for it. I don't know. Probably not, so maybe just get another sheet of paper. I don't know. Before we do it, though, I'm going to help you find the upper bound and the lower bound so that you don't have to just start plugging in all those P over Q's, okay? So the first thing you do is you make this chart, and my lines are missing, so let me draw them in. It's like a box chart thing, okay? And this is called your 0 row. This is called your 0 row because it's a 0. Guess where those numbers come from? Any guesses? Probably the equation. Look, they're just the coefficients. Now, if you were checking my paper, you would not see any of this. You wouldn't see this. You would just see row after row after row, okay? But I want you to understand where in the world did she get that row from? So that's why I have this over here, okay? Now, what you do, 0, the next number that's positive bigger than 0 is 1. You know, we're using integers, okay? We're not using fractions. So I'm going to use 1. Bring down the 3. 3 times 1 is 3. 4 plus 3 is 7. 7 times 1 is 7. Negative 7 plus 7. 0. 0 times 1, 0. Bring down 2. So now over here, record those numbers. 3, 7, 0, 2. Are those numbers positive? Are those numbers negative? Are those numbers alternating in sign? They're all positive because 0 can be whatever I need it to be. So if you find a row of all positives, this is called your upper bound. So what that means, do not waste your time plugging in numbers bigger than 1. And let me explain why you look for positives. If they're all positive, it means if you plug that number in, it's just shooting off towards infinity forever because they're all positive. So it's never going to come back down and cross the x-axis. That's why we look for all positives, okay? So plug in 1. If 1 had not worked to give me a row of positives, I would have then plugged in 2. If that didn't work, I would then plug in 3. And then you're going to find it, okay, eventually. But because it did work, I don't need to keep plugging in positive numbers. Now I need to plug in negative. So what's the closest integer to 0 that's negative? Negative 1. So if you need to, go over here and work it. Negative 1. And then, yes, use that original row again. 3, 4, negative 7, 2. Bring down the 3. And then finish it. Mm, 3, 1, negative 8, 10. Is that alternating in sign? So I guess that doesn't work. It's not alternating in sign. So it's not my lower bound. You notice I put a UB right here for upper bound, right? You saw that? Come in. That's okay. All right. So now we're going to try negative 2. Go ahead and do the work over here. I'm just going to do it over here like I normally would, but go for it, okay? Negative 2 doesn't work. Does it? Is that what y'all got? Check my math for me, please. So negative 2 didn't work. We got 3, negative 2, negative 3, 8. Right? I do the math by just adding and stuff, so you're not seeing all of this, but that's literally what I'm doing, okay? So what am I going to try now? Negative 3. Just to see? No, always stair step up. Okay. Go ahead and see if negative 3 works. Do it. Negative 3 times 3 is negative 9, plus 4 is negative 5, 15, 8, right? So we get negative 24 plus 2 is negative 22. Look at that. We have a positive, then we have a negative, then we have a positive, then we have a negative, which means this number right here is my lower bound, meaning I should not try any number less than negative 3. You see what we're doing now? Everybody? All right, so I'm going to paste this to a new page, and I'm going to write what I just discovered. That the upper bound, yes, your separate sheet now, yes. What's the upper bound? 1. What's the lower bound? Negative 3. So now I'm actually going to start trying to find my actual zeros and stuff, right? So how do I do that? How do I find what my zeros could possibly be? P's and Q's. Mind your P's and Q's, right? So what was P? P is 2, which has factors of plus or minus 1, plus or minus 2. And Q? 3. So my factors? Plus or minus 3. So my P over Q, I don't know why I did a capital Q. Why did I do that? Wow, I don't think I've ever had that happen to a student, and I've been teaching 9 years. Nothing. It's cool. Keep going. How do I find P's and Q? P over Q? Divide. So 1 over 1 is 1. 1 over 3, 1/3. 2 over 1, 2. Y'all, 2 over 1, 2 over 3. That's why I stack them that way, P and then Q, and get P over Q. Okay, so I like them in order. No, you don't have to do this. All right. Why is that helpful? Put them in order. Should I try positive 1? Should I try positive 2? Okay. And then your lower bound happens to actually be less than all of those, so you might have to try the negatives, yeah. But on that question a while ago where we had 12 choices, it would help to find the lower bound. But on this one, you don't have as many choices. But still, I know not to try 1 or 2 now at least, right? Yeah. Okay, so what else should I do that might help me? Descartes rule. Descartes rule. So how many sign changes? Positive, 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 negative, and then negative, positive. Ah, 2. So positive real zeros. We are going to have 2 or 0 because we always subtract 2 until we get to 1 or 2. Okay? Negative, what do I got to do first? F of negative x, which gives me negative 3x cubed because that's an odd number. Thank you. Then this is even exponent, so it stays positive. Then this is odd, so it's going to become positive, and then plus 2. So how many sign changes? 1. So how many negative zeros do we have? 1. We definitely have a negative real zero, but again, it may be irrational. So again, if you try negative 1/3, negative 2/3, negative 1, negative 2, and none of them work, don't think you made a mistake. It just could be irrational, okay? Alrighty, so what do you want to do? I would probably use that upper bound and maybe try 1/3 and 2/3, maybe, right? To see if either one of those work, because if they don't, then it makes me feel like 0, right? Like there's no positive reals. I mean, that's what but that's just me. What do you want to try? You prefer negative 2/3? Don't listen to him. You want to meet him in the middle and try 2/3 positive instead of negative? It's all or nothing. I'll meet you in the middle. I'll give you 2/3, but let's try the positive instead of the negative. 3, 4, negative 7. You do not quit. Stop it. They were in order, right? Okay. And they're not missing anything, so I don't have to put a 0. Bring the 3 down. 3 times 2 is 6. 6 divided by 3 is 2. I'm sorry, mind your way. 4 plus 2 is 6. 6 times 2 is 12. 12 divided by 3 is 4. Negative 7 plus 4 is negative 3. Negative 3 times 2 is negative 6, but negative 6 divided by 3 is negative 2. What? Ooh. We started as a cube, didn't we? Did we start as a cube? Oh, so look at that. Now we are a quadratic, a second degree. So this is 3x squared plus 6x minus 3. So I'm going to set it equal to 0 to try to find my other roots, right? Slide and divide, will that work? Ah, we always, y'all, always. GCF, always. And then if you still needed to do slide and divide, you could. Which gives me 3 times x squared plus 2x minus 1. And then while I go, set your factors equal. Can you factor to get negative 1 when you multiply, but add to get positive 2? What's going to give me negative 1? Positive 1 and negative 1, right? When you add those together, what do you get? 0. So what am I going to have to do? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Here's the deal, y'all. I know that formula. I write it every time for your benefit, not for mine. You just know it because of the song? Hey, what's B? The 2. This is B. This is A, and this is C. And yes, you would plug in negative. So we get negative 2 plus or minus 2 squared minus 4 times 1 times negative 1. Make sure you plug in the negative for C. All over 2 times 1. So we get negative 2 plus or minus 4 plus 4, because negative 4 times negative 1 is positive, all over 2. And that gives me negative 2 plus or minus 8 over 2. And do we ever leave radicals like that? No. What goes into 8? 2 and 4, but 4 is 2 and 2. And how many does it take to bring out 1? 1, 2. So I get negative 2 plus or minus 2. And then what's left under the radical? That number, 2. Whatever you didn't circle. All over 2. Whew, are we done? It reduces. If you have a 2, and a 2, or a 2, and 8, and a 2, you know, they're all even, it reduces. So it's going to be negative 1 plus or minus square root of 2. What did you just discover? There's one real rational 0, and there's 2 irrational zeros. But they're both still real. They're not imaginary. Okay? So that would be negative 1 minus square root of 2, which is negative. So there's my negative, right? And did you see that's not bigger than negative 3, is it? Or further away from 0? No. Hey, y'all, I will post your homework on Blackboard, and I'll also get you your feedback for the recipe. Did everyone hear me that if I don't get it to you, you know, I'm going to West Virginia, so if I can't use CamScanner and email it to you because I don't have service, then I will push the deadline back from Sunday night at 11:59 to later, okay? I'm owning it because I'm the one that hasn't given it to you. I will post your homework. Have a fabulous weekend.